All right, here I am, 8.5, common logarithms and natural logarithms. Now we've been doing logarithms up to this point that had bases on them like 2 or 8 and pretty much any number that you could come up with. And today we're going to start doing some logarithms that have a base of 10. All right, and because they have a base of 10, they're a lot easier to work with. And in fact, we use base 10 so much that we don't even write the 10 on here. So when you just see a logarithm, such as the log of 100, there is no base there, so therefore it's an assumed 10. So let's go back and just review real quick as far as what these logarithms look like as far as changing them back and forth from logarithmic to exponential form. So if I had the log of, let's say, 100, I am asking what number can I put on 10 to give me 100. That being the case, I have to have a 2 up there. So x equals 2. Now that's how you do it in your head. If you were to do it mathematically, I would write this as 10 to the x equals 10 squared. So remember, if we get the bases the same, then the exponents have to also be the same. So that's just another way of doing that. So on your calculator, in fact, let me pull up a calculator here onto the screen so you can get an idea of what we're talking about. Now, gosh, every one of you's probably got a different calculator. And this is one that I just grabbed off the internet. So yours may look similar to this, it may not. But you have a key, a couple keys right here. Let me get some color on here. You've got a log key and a 10 with a little box up there. Some of the boxes might be open, like this one. Some of them might be filled in, like this one. Some of them might have the number X. So instead of having a 10 with a box, it may have an X up there. They all mean the same. And we'll get into using all of these keys. In fact, what we'll be doing is using all of these keys right here in this section. So if you ever wondered what those keys were for, we are going to explore those things. I know, super exciting, isn't it? All right, so I'm on page 692, and we're going to look at example 1. And it gives us, let me get my right ink here, and I'm sorry, my hand's writing is so shaky. I know it's like, well, it's not worse than it was on any of the other ones, but here it is, 2,760, the log of 2,760. So the way you do this on your scientific calculator, if you have a calculator similar to the one there on the right, you push on the numbers 2760, that's 2,760, and then you push the log key. And it should give you a number similar to 3.4409, and it goes on to infinity. It just keeps going on and on. All right, if you're not getting this number when you practice that on your calculator, you might have to put log in first and then this number. So it's going to be one or the other. It just depends on the calculator. The number, then log, or the log, then the number. So try that one. Also try the log of 0.0391. This is example number 2. And you should get a number similar to 1.407 8. Okay, so if you put in 0.0391 and you hit the log key and you get this number, that means you have your calculator figured out. If you're not, try it in a different order and see if it actually will give you that number. It should. Okay, so let's look at, let me erase all of this stuff. And let me put back up here the log of 100. That is actually the log with a base 10 of 100. But remember I said since we're dealing with just common logs, if there's not a number in the base, like right here, it's an assumed 10. So I put the 10 there just to show you that it's there, because what this means is, what number can I put on 10 as an exponent that gives me 100? And in this case, x is going to be 2. If we square 10, we get 100. Okay, so let's look at some that are a little weird looking. All right, so if I had something like the log of 7.02. All right, what that is saying is, what number can I put as an exponent of 10 that gives me 7.02? Okay, so all that to say, if we had a 2 up here for x, that would give me 100. What if I had a 1 up here for x? Well, 10 to the first power is 10. So if we're trying to figure out what number we want to put on 10 that's going to give me a number like 7.02, it's going to be a number less than 1, because 1 gives me 10. So that just kind of gives you an idea that the number that's going to have to go up here is going to have to be less than 1. And in fact, when you put it in your calculator, you get 0.8463, which means you multiply 10 by itself, 0.8463. Now that makes my head explode. You can't multiply it by itself, 0.8463. I don't get the logic behind that personally, never have. But that's what you end up getting, a number less than 1. All right, so we did example 1. We did example 2. Let's jump to example number 3. I need to keep that calculator handy because we're going to be using that in a minute. So we have the log of 0.00523. So again, if you wrote it in exponential form, what number can we put on 10 as our exponent? That'll give me this number for an answer. Well, it's going to be a stinking tiny number because this is a stinking tiny number. So in fact, our x value is going to be negative 2.2815. So that'll end up being your answer for that. Now, some students are like, well, why the negative? Where does that come from? That is so far beyond the scope of this book. We're just plugging in the numbers and writing the answer down as we're finding the exponent. So just a key thought here. When they give you a log and there's a number here, what they're asking for is, what is the exponent that we put on 10 that gives me this number? That's what they're asking you to do. Okay, this next section is called anti-logarithms or anti-logs. It just means that we're going backwards here. So, like I said before, what this says is, what number can I put on 10 to give me this answer? So, just like here, what number can I put as an exponent of 10 that gives me this number? Okay, let me erase this because I don't care what the answer is. I just want you to understand where it comes from. Okay, so that's where we're looking for in this one is x. We're looking for the exponent. The anti-logarithm is looking for this number. So, for example, if I said the log of x equals, 3.8774. This is example number 4, by the way. This is saying if we put 3.8774, again, I apologize for my writing. If we take 10 to that power, what number do we get? Okay, so up here, we got the number. We needed to find the exponent to put on 10. Down here, we've been given the exponent, and now we're putting it in as an exponent of 10 to see what we get for an answer. So that's the anti-logarithm. All right, so that being the case, let's go back to our handy-dandy pretend calculator here. Come on, move. All right, so if I can get rid of that big old arrow. So we have another, let's make this even bigger. We have another key on here, same key, different function, right here. That is the anti-logarithm key. That number right here, if I ask you from, well, let me just write it back up here. Log of x equals 3.8774. All right, so what I'm asking you to do is find a number that is to 10 to what power? This power, 3.8774. If I take 10 times itself, 3.8774, what answer will it give me? It will give me 7,540. All right, so the way I do that with a key when I'm given logarithms, notice that when I'm doing anti-logarithms, I have a variable here because this is the answer that I'm looking for. This is the exponent that I put on the base, which is 10. So 10 to this power gives me this answer. In this case, it's 7,540. So what I do with my calculator is I put in 3.8774, the only number they give me, okay? Then I push this key, which means I have to push the function key, or the shift key on my calculator. In this case, it's right here. So I put 3.8774, shift, and then I hit the log key because that shift key means that it will work. It'll do this. So it's saying I'm going to put 3.8774 in for x. That's what this little box means. I'm going to put that number right here, and then it will automatically go 10 to that. So once you push 3.8774, shift this key, hit equal, and it'll kick out a 7,540. That's what you're looking for. So this is the exponent that we put on 10. What answer do we get when we do that? And that's what our 10 to the x key is for here. So another one for you to try. In fact, let's get rid of my little calculator there. Log of x equals negative 2.4179. So again, 10 to the negative 2.4179 equals x. So you're going to use your calculator and use your 10 to the x key, and it will give you 0.00382. Now, when I was taking this class back in the olden days, there were no such thing as calculators. Half of the book was a table full of logarithms of pretty much every number you could come up with so that you could get these numbers here just by looking it up in the book. Now, fortunately, we have calculators, and you don't have to do that. You push a couple buttons, and you're good to go. Okay, so I am going to go ahead and stop this video and go into 8.5. B as in Bravo, since we're already at almost 15 minutes.